Diane Schuler, and today I want to talk about the intuition behind p-value. So let's say you have a coin and you're wondering whether or not it's a fair coin. In other words, is the probability of a head equal to 0.5? So you decide to toss the coin 20 times. X is your random variable, which is the number of heads, and you get 15, for example. The p-value is going to be 2 times the probability of obtaining 15 heads or more, assuming that the probability of a head is 0.5. So assuming the coin is fair, what's the probability of obtaining the result that you got or something more extreme? And by something more extreme, we mean the following. So if you look below at the binomial distribution, these are all the possible outcomes you could have. You could have 0 heads, 1, 2, all the way up to 20, because you're tossing the coin 20 times. And this distribution curve gives you the probability of obtaining any one of those individual outcomes. So the probability of obtaining a 15 is this little bar, and something more extreme than that could be 16, 17, 18, 19, or 20. And the reason why we have to multiply it by 2 is because we didn't say, well, we're wondering if heads is going to be more common than tails. We didn't give a direction to it. We just said, is it fair or not? So is P equal to 0.5? The probability of heads is equal to 0.5, or is it something different? So we have to look at all the values on the lower end also, from 5 down to 0. That would all be included. So the way we do that is we say, and if we're doing it in Excel, we would say for the probability that X is greater than or equal to 15, that would be 2 times, and since the Excel function and also the TI-84, it only gives us the less than or equal to. So if we just put in 15 out of 20, it would give us the probabilities, including 15, but all the way to the left. And we want to the right. So we have to take 1 minus the probabilities to the left. And the reason why we're using 14 for our X value is because we don't want to include 15, because we're taking 1 minus it, and we want to be left with the 15, 16, 17, 18, 19, or 20. So it's 1 minus the binomial distribution where X is 14, total N is 20, 0.5 is the probability of heads, because that's, under H0, under the null hypothesis, it's 0.5. And true just means you're using the cumulative distribution function. And then for the TI-84, it's similar. Their function is binom CDF, and you use N of 20, P of 0.5, and X of 14. And you end up with a result of 0.0414, or about 4%. So a result of 15 heads out of 20 tosses of a fair coin would be surprising. That should only happen, or a result more extreme, 4% of the time if the coin is fair. So maybe the coin's not fair. The conclusion would be, if our significance level, for example, was 5%, the conclusion would be to reject that the coin is fair. There's convincing evidence the coin is not fair. The p-value interpretation is also the probability of a type 1 error. It's the probability of observing your result or something more extreme given the null hypothesis is true. In this case, it's given the coin is fair. Thank you.